Welcome to The Explainer. Have you ever stared at a really tricky coding challenge and just had no idea where to even start? Well, today we're going to break down the framework that turns that confusion into clean, working code. We're talking about the problem-solving process.
So here's the game plan. We're going to walk through 5 key stages, starting with the absolute basics of how a computer thinks, and we'll end up with this really powerful loop that you can apply to pretty much any problem you face. All right, let's get into it.
Okay, first things first. Before we can tell a computer how to solve a problem, we really need to get how our main tool, the computer itself, actually works.
I mean, it can feel like total magic, right? But what's happening behind the curtain isn't genius-level thinking. A computer is more like a lightning-fast, perfectly obedient assistant that only does exactly what you tell it to do, nothing more, nothing less.
See, it doesn't think like we do. It just executes a super precise set of instructions, that's the program, to turn some input into a specific output. That's the whole game, right there. Input, process, output.
And deep down, at the very heart of your computer, there's this simple, relentless cycle happening billions of times every single second. It fetches an instruction, decodes what it's supposed to do, executes that command, and then stores the result. Fetch, decode, execute, store. Over and over. It's literally the heartbeat of computation.
So, if the computer just follows instructions, then our main job becomes giving it the right instructions. And that all starts with what is probably the most critical step of all, deeply, truly understanding the problem you're trying to solve.
You know, you can think of this like putting on 2 different hats. First, you put on your detective hat. You use analytical thinking to break the big, messy problem down into its smallest, most understandable parts. Then, once you've got the whole scene mapped out, you switch to your architect hat to actually design and build the solution. You've got to analyze first, then act.
All right, to make this whole process a bit more real, we're going to use this simple little challenge for the rest of the way. Find the largest number in a list. It sounds easy, and it is, but it's the perfect way to see this whole framework in action.
Now this is the part where we force ourselves to slow down and not just jump straight into writing code. A clear problem statement is like a blueprint for a house. It makes us define exactly what we're starting with, what we need to end up with, and what rules we have to play by.
The next step is to create a simplified model of the problem. We want to strip away all the real-world messiness and just represent the core issue. For our challenge, the model is super simple. It's just an abstract list of numbers. This lets us focus purely on the logic, not on where the numbers came from or what they mean.
Okay, so with a clear model in hand, we can finally start designing a step-by-step plan, a recipe, if you will, to actually solve this thing.
And this right here, this is the heart of the solution. The algorithm isn't the code itself, it's the pure logic that the code is going to follow. You gotta get this right, because if your recipe is bad, your cake is gonna be bad, no matter how fancy your oven is.
So, our recipe for finding the largest number is actually pretty straightforward. First, we need a place to keep track of the biggest number we've seen so far. Let's just assume the very first number is the biggest, just to get started. Then, we just walk through the rest of the list, one number at a time. If we find a number that's bigger than our current champ, we have a new champ. We just keep doing that until we've checked every single number.
And only now, once we have this solid, language-independent algorithm, now we can finally translate that logic into an actual program using something like Python or Java. You see the order? Logic first, implementation second, always.
But hey, writing the code is not the end of the road. Not even close. Now comes the hard part, making sure it actually works, and works well. And that absolutely applies to our code. I mean, almost no program works perfectly the first time you write it. And that brings us to this super important phase of refinement, making sure our solution is not just clever, but actually correct. So this means we have to be our own biggest critic. We have to test our code with every weird scenario we can dream up. What if the list is empty? What if it's full of negative numbers? We hunt down those bugs and squash them. And then we step back and ask the big question. Is this solution just correct, or is it good? Could it be faster? Could it use less memory? So, we've walked through all the steps, but here's maybe the most important insight of all. This is not a straight line from start to finish. It's really a loop.
And this, right here, this shows you the true nature of great problem solving. It is not a one-way street, it is a feedback loop. Testing might uncover a huge flaw that sends you right back to rethink your algorithm. Evaluating might show you a way more efficient approach, making you scrap your whole model. Every single time you go through this cycle, your solution gets stronger and better.
You know, this process, it's not just for coding. It is a powerful framework for tackling any complex challenge you can think of. Whether you're building a business or just planning a big project, it's a way of thinking. So the real question is, what will you solve with it? Thanks for tuning in.